My name is Dr. Esther Trufan, and in this video, I am going to demonstrate how to collect the measurements you need to determine the density of a regular solid. And what we mean by regular solid is a regular shape, either rectangular or cube. And I have an assortment of different materials right here. All of them are cube shaped. For this set of measurements, we're going to use a ruler. I have a ruler here, and I'm going to place my cubes on a piece of white paper so that the contrast is a little bit greater between the item and the paper. But you do not need a paper under your cubes. Because for density, we need mass and volume. For the mass measurement, we're going to use a scale. And in order to avoid placing our cubes directly on the surface of the scale, we will be using a weighing paper today, but you could use a weighing boat instead. Here is my scale. And I have some weighing paper in this beaker. I'm going to select this gray cube. And then I'm going to make 3 measurements. For volume measurement of a regular object, it's going to be the product of length times width times height. And I am assuming that this is a cube, but there's nothing that beats the evidence of proving it. So I am going to place my ruler so that my first gradation is neatly lined up with the left of my cube, and I am going to measure it all the way to the right. In order to record our length measurement, we're going to assume that we start at the 0 mark, and we're going to figure out exactly how many decimal places will follow that 0. And it goes all the way to the 2.5. Except if we have it correctly oriented, it goes slightly over. And when we look closer, it is between 2.5 and 2.6, and it's very, very close to the 2.5. So we are going to estimate another number after the 2.5, and that will be a 1. 2.51 centimeters is our length measurement for our cube. Now we are going to take our ruler to the side, and we are going to turn our cube 90 degrees. This is going to be our width measurement. So we're going to do the same thing. We're going to place our ruler the same way. Our left edge is going to line up with the 0. And then our right corner is where we're going to record our measurement. It seems to be exactly on the line. So 2.5. But because we are making the efforts to record another digit, we're going to make an estimate. Because it's exactly on the 2.5 line, we're going to say it is 2.50. So the difference between the 2.5 and the 2.50 is that in the 2.50, we made the effort to estimate the value. The value just simply happens to be 0. But it is important that we record that in our data collection. Then we are going to take our cube and we're going to turn it either towards us or away from us. And this is going to give us our height measurement. We're going to place the bottom of our cube right at our 0 marking. And then we are going to record the measurement at the top. It is just a little further from our 2.5. So if we look closely, it exceeds it by just a hair. And we're going to make that estimate. It is 2.51 centimeters. The product of these 3 values that we measured, 2.51 times 2.50 times 2.51, is going to give us a number. And the product of our units, centimeter by centimeter by centimeter, is going to give us the cubic centimeter that is the volume unit. Now that we have our volume determined by measurement of the 3 lengths, width, and height, we are ready to determine the mass of our object. We will turn on our scale, take a weighing paper and place it on top. We press the T button. That will tear the measurement. It goes to 0.00, and then we place our object on the scale. At this point, we're going to record the mass of our object in grams, and this object weighs 23.00 grams. With the mass and the volume of our object recorded, we can proceed and determine the density. Once we are done with our object, which is currently marked 8, we can proceed and extract more objects and determine their densities in the same manner. you.